Okay, in this video, we're going to talk about covalent bonding. We've talked previously about single covalent bonding and how to draw a dot cross diagram. And now we're going to talk about when you have a double bond or a triple bond. Now, you said in a single bond, you have atoms share one pair of electrons. Two atoms share one pair of electrons. In a double bond, they share two pairs, so 4 electrons altogether. In a triple, they share 6 electrons, 3 pairs. Now, in the previous video, we established that carbon, anything in group 4, forms 4 bonds. So carbon, mostly. Anything in group 5, that always forms 3 covalent bonds. Anything in group 6 will form 2. Group 7, it will form 1 covalent bond. Okay, so now let's think about what happens when you get, say, F2 now. Okay, so F2, we know that is probably going to be a single bond between the two fluorines, because look, fluorine it's in group 7, it should be forming 1 bond. So it is just a single bond between the two fluorines. So let's draw a dot cross diagram for that. So we follow the instructions on the left for drawing our dot cross diagram. So number 1 in blue, it says draw a dot and a cross in the overlap. Done that. Then in black it says, for each atom, how many of its own electrons should it have, and do we need to draw any extras? Well, fluorine is in group 7, and for this fluorine here, I've only drawn 1 dot, so I need to draw 6 more. 1, 2, 3, 4, 5, 6. And the same for this fluorine, I've only drawn 1 cross, so I need to draw 6 crosses. Now, number 4, it says check each atom has a full outer shell. Well, each fluorine there, you can see each one thinks it's got 8. 1, 2, 3, 4, 5, 6, 7, and 8. Same for the other one. So that is the correct dot cross diagram, and a single bond would appear to be the right thing to draw. Okay, now let's go to oxygen, O2. Let's do oxygen, and right, we can see we probably have a bit of a problem there, because oxygen likes to form 2 bonds. So if we have that, there's no way that either oxygen would be happy. They're only forming 1. So the only way they can bond together is by draw 2 lines. That means it's a double bond. That means they're not sharing 1 pair of electrons, they're sharing 2 pairs. So when I draw the dot cross diagram here, step 1, it says place a dot and a cross in the overlap of each bond. Well, because this is a double bond, we don't just put a dot and a cross, we put a dot and a cross and another dot and a cross. Okay, because it's a double bond. So there, okay. So now we have to think oxygen is in group 6. So this oxygen, I have drawn 2 dots. So I need to draw 4 more. So 1, 2, 3, 4. And this oxygen, the same as in group 6, I've only drawn 2 crosses, so I need to draw 4 more crosses. Okay, so there we have got, let's final step. Check each atom has a full outer shell. Let's do that. Well, this oxygen thinks it's got 1, 2, 3, 4, 5, 6, 7, and 8. And the same with the other one, it thinks it. So that would be the correct dot cross diagram. Now let's just see if we hadn't realized that oxygen forms 2 bonds, and let's think we thought it was a single, what would happen? Because some people do it this way, right? So they draw their oxygens like this, and they put a dot and a cross. The step 1, dot and a cross, and then step 2 in black, it says, well, you've got to make sure they've got the right number of electrons. Each oxygen should have 6. I've only drawn 1 here, so I need to draw 5 more. 1, 2, 3, 4, and 5. And the same for this one. 1, 2, 3, 4, and 5. Okay, now would that be happy? The final step, the in red. Right, let's count up the oxygen, the number of electrons. You can see no, it wouldn't, because it thinks it's got 1, 2, 3, 4, 5, 6, 7. That is not a full outer shell. It wouldn't like that. So what some people say is, right, then you can say, right, then that one and that one, let's get rid of them and put them in there instead. Okay, and then that works. Each oxygen would think it's got 8 electrons in its outer shell. So that's maybe another way of doing it. But I think it's probably easiest just to remember how many bonds each element from each group forms. Right, let's do nitrogen now then, which is N2. Nitrogen is N2. Now nitrogen likes to form 3 bonds, so it couldn't be that. It wouldn't like that. It couldn't be that. Each nitrogen would only be forming 2, but if you have a triple bond between them, then that would work, okay, because each nitrogen is forming 3 bonds. So let's just quickly draw a dot cross diagram for that, see if it works. So okay, so in the overlap, because it's a triple bond, we don't just put a dot and a cross, we put, just about squeeze that in there. Okay, so you've got 6 electrons in there. Now nitrogen is in group 5. This one, okay, I have drawn as dots. I've only drawn 3 dots, so I need to draw 2 more. One there, one there. Same with this one, I've only drawn 3 crosses, so I need to draw 2 more crosses. Right, now how many electrons does the nitrogen, the red step, does each one think it's got in its outer shell? It thinks it's got 1, 2, 3, 4, 5, 6, 7, 8. So yeah, it thinks it's got a full outer shell, so that works. I'll do one more example here. Right, this is, let's think about if we had the molecule hydrogen cyanide, HCN. Okay, so we know that carbon likes to form 4 bonds, because it's in group 4. Nitrogen likes to form 3 bonds, because it's in group 5. And hydrogen always forms 1 bond. Okay, so if we drew something like this, C, let's try that. Carbon wouldn't be happy, that's only forming 3 bonds, and nitrogen wouldn't be happy, it's only forming 2. But if we make that a triple bond, then yes, the carbon thinks it's forming 4, the nitrogen thinks the carbon's forming 4 bonds, the nitrogen's forming 3, the hydrogen's forming 1. So that should work if we drew a dot cross diagram for that. I won't draw it for that one because it's not such an important molecule, but I'm going to draw a really important molecule, carbon dioxide, CO2. How does that work? Right, carbon likes to form 4 bonds, oxygen likes to form 2. Right, so how is it going to work for carbon dioxide? Well, if you had a double bond to one oxygen and a double bond to the other, yeah, the carbon's forming 4 bonds, each oxygen's forming 2, so that should work. Let's try draw a dot cross diagram for that. Try and draw a better circle than that. That's an awful circle. Okay. There's carbon, there's oxygen. Right. In the overlaps, you put a pair of electrons in there, but it's not a pair because it's a double bond, so we put in 2 pairs in each one. By the way, I'm going to do carbons as crosses, and I'm going to do the oxygen electrons as dots. Okay, so I need to do that. Okay, now carbon is in group 4, so it's got 4 electrons in the shell. Have I drawn 4 crosses already? Yes, I have, so I don't need to draw any more outside of the bonds. Let's look at oxygen. Oxygen is in group 6. I've only drawn 6 electrons in the outer shell. I've only drawn 2, so we need to draw 4 more. And the same for this one. Right, let's check all the atoms think they've got a full outer shell. Well, we can see that the carbon thinks it's got 8, because it's got 4, 1, 2, 3, 4, 5, 6, 7, 8. And each oxygen thinks it's all got 8 as well, so it's got 1, 2, 3, 4, 5, 6, 7, and 8 for each one. So that's the correct dot cross diagram for carbon dioxide. Okay, put that electron back. Right, So drawing dot cross diagrams is a very powerful and very useful technique when looking at where the electrons go. In covalent bonds.